Hello students, and welcome to the 6th video of this 7-part series. There's just 2 videos remaining where we're going over related rates. In this video and the next video, you're going to see more about what a multi-part related rates question will look like. So let's get started. So here we are, we're looking at a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So I know I haven't written anything down yet like I have in the previous problems, just because I wanted to really get a picture of what's happening. So there's a ladder leaning against the wall, and then there's the ground, and then there's the wall. All right, so in my mind, when I think about this, I am thinking of a triangle, and that right there is the ladder. So that's going to be, I'm going to label that one as my Z side. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So here's the base of the ladder right there, that's X. And so that X, that horizontal distance, is going to start getting longer and longer. And so it's a rate, so it's going to be dx dt, okay? Now we want to know how fast is the top of the ladder moving down the wall when the base of the ladder is 7 feet from the wall. So we're going down, and so we want to know what is the speed. So what's happening is, all right, so maybe there's some sort of roof worker, they have a ladder. Maybe that ladder wasn't secured properly, and so the base of the ladder is sliding out away from the wall. As the top of the ladder starts sliding down the wall, it's going to, because of gravity, it's going to start picking up speed. And so based off of the rates, it's going to go slam right down onto the ground. We want to know, what is that rate? How quickly is it going to slam down onto the ground? And so some people have just asked that question. And with calculus, we're able to answer that question. All right, so I'm going to start with, what do we want to find? What do we want to find here? Well, we want to find dy dt, because we want to know that y-axis. We want to know how it's moving down. And we're given here, what are we given? We're given the z value. We're given the x value, because it's 7 feet from the wall. That's going to be x. And we're given the rate, so dx dt, okay? And one thing that I do want to know is that the z remains constant, because think about this. We're going to be thinking about this situation where the ladder is falling, right? The x distance, the horizontal distance, the base of the ladder is always going to be moving away. The top of the ladder is always going to be moving down, but the ladder length is always going to be 25 feet long. So that's going to be something that is always going to remain constant, okay? So what I want to do here is I'm going to relate the 3 sides of a right triangle, and that's going to be the formula x squared plus y squared equals z squared. And I'm going to substitute in the 25 here because it remains constant, all right? So that's going to be x squared plus y squared. And then I'm going to differentiate this. So that's going to be 2x dx dt plus 2y dy dt equals 0. And now I am going to substitute in the values that I have, okay? What can I find? What can I work with here? Okay, so 2x dx dt. So 2, and my x value is 7 feet. And then dx dt, that is 2 feet per second. It's getting longer, so it's going to stay positive. So then that's going to be 2 feet per second plus 2y. I don't know what y is. And we also don't know dy dt, because that's what we want to find. So 2y dy dt equals 0. And this is kind of what was happening before. This is where I know I need to find something else, because there's 2 variables there. So there must be some way I can relate these things, all right? Let's just keep moving forward with this and clean it up, and then we're going to go find one of those values, probably y, because we want to find dy dt. All right, so 7 times 2 is 14 times 2. That's going to get me 28. And then feet times feet, that's square feet per second plus 2y dy dt equals 0. We'll come back to that. I'm going to just hold on to that for right now, okay? And so I'm going to do some work over here on this side. And we still have a right triangle. And we still have this formula x squared plus y squared z squared. All right, so we know at the point, the instantaneous point, that x is going to be 7 feet. And that the z, the ladder length, is always going to be 25 feet. So I could figure out what that value for y is. And once I figure out what that value for y is, I can substitute it back in here to this y and solve for dy dt right there. So that's what we're going to do. All right, so I'm going to get, all right, so 7 squared plus y squared equals 25 squared. So I'm going to get 49 plus y squared equals 625. And then subtract that, so y squared equals 576, and then the square root of that, y equals the square root of 576, which is 24 feet. Again, we know that that vertical length is always going to be in feet here. Okay, so we know that that y value is going to be 24 feet. So we can actually start to come back here, substitute that in to that y right there, and figure out what we need here. All right, so I'm going to substitute that in. I'm going to subtract the 28 feet squared to the other side. So I'm going to get 2y, and we just figured out y right here is 24 feet. So I'm going to go 24 feet right there. Dy dt equals negative 28 square feet per second. Okay, so let's bring this up here because we'll work with it over here. So 2 times 24 feet, I'm going to get 28 feet. Nope, that's not right. 48 feet. There we go. 48 feet dy dt equals negative 28 square feet per second. And then I'm going to divide by 48 feet on both sides. Divide by 48 feet. And again, look at that unit analysis, square feet over feet. We know one of those is going to divide out. So I have dy dt, which is what we want to solve for. Dy dt equals, let's see, 28 over 48. Those can both be divided by 4. So I'm going to get negative 7 over 12 feet per second. All right. So how fast is the top of the ladder moving down the wall when the base of the ladder is 7 feet from the wall? Well, we know here that it's moving down at negative 7/12 feet per second. But what we want to do is actually say that in a phrase. So we're going to say the ladder is moving down the wall at a rate of 7/12 feet per second. Okay, you might be looking at that and you say, Mr. Hernandez, right there you have negative 7/12. But when you wrote your answer, you wrote positive 7/12. Did you make a mistake? No, I didn't make a mistake there because I said it here in our phrase that we're moving down. Okay, so by moving down, as a calculus teacher, as a calculus student, as a calculus reader, we know that rate is negative because it's decreasing, okay? And I say it by moving down. So you can either say we're moving down at a rate of 7/12 feet per second, or you can say you're moving up at a rate of negative 7/12 feet per second. And honestly, that second phrase makes absolutely no sense in the vernacular. So we're going to say we're moving down at that rate, all right? So be very clear about what you're saying and how you're saying it from these particular values, because this is the meaning. We're moving down. That's the meaning of this problem. All right, so now let's take a look at what we can move on to. So consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. Okay, so great. We've already done a lot of this work. So let's think about, okay, area of a triangle. What do we want to find here? So we want to find area of a triangle. We want to find the area of the triangle is changing. So we want to find dA dt. All right, so area of a triangle, that formula is going to be 1/2 base. So we're going to go x times the height, and so we're going to use y here. Okay. Do any of those things remain constant? Does that x remain constant or that y remain constant? And so in part A, we know neither of those remain constant, so we're actually going to have to use the product rule. So dA dt is going to be the derivative of the first, so that's going to be 1/2 times y dx dt plus the first 1/2 x times the derivative of the second, which is dy dt. All right, and so from part A, we know that when x is 7, that y is going to be 24 feet right there. So we can make those exact same substitutions. So dA dt equals 1/2 y, which is 24 feet, dx dt, which is still a rate of 2 feet per second, because it's the same problem, it's just part B. So 2 feet per second plus 1/2 x, which is 7 feet given to us. And then dy dt, we found it in our previous problem. It was 7/12 feet per second, but it was negative. So dy dt was negative 7/12 feet per second. So what you can do here is like, okay, everything comes from part A. We can just take that from part A and use it in part B here. Okay. Now I will say that on the AP exam, if you have an incorrect answer in part A and you use an incorrect answer in part B, you're not going to get penalized twice. Keep going with that answer. Don't worry about it. You're going to get points in part B if your work is correct here. Okay. So let's see what we can do here. So those 2's, I see these 2's are going to divide out, and then I don't see anything else happening there. So then we're going to get 24 square feet per second plus 7 times 7 is 49. And then 2 times 12, that is 24, but it's negative. Okay, because that's a negative 7/12, so it's going to be minus 49 over 24. Feet times feet is square feet per second. Okay. And I am going to subtract those, and honestly, just at this point, just throw that into your calculator, because we are going to look for a decimal answer, or honestly, just leave it like that. You don't need to simplify after any of this stuff. Okay. So we are going to go all the way down to the end and simplify with our calculator, and you should come out to be approximately, the area is changing at a rate of approximately 21.958 square feet per second. All right, so that's the rate that the area is changing when the ladder is when the base of the ladder is exactly 7 feet from the wall. All right, and now moving right here to the final problem in this video. We want to find the rate, again, a rate, at which the angle formed by the ladder and the wall of the house is changing when the base of the ladder is 9 feet from the wall. So we're gonna note that the base has changed from 7 feet to 9 feet. Let me draw kind of a picture here. All right, there's the picture. I'm gonna put in the angle. Actually, wait, the angle formed by the ladder and the wall. Oops, well, that's not right where I put that angle. Don't want to get just caught up making the random stuff happening. So the angle is the ladder and the wall. All right, so that's going to be at that top part right there. And so we know X is going to be 9. We know that our Z hasn't changed. That's still going to be 25 feet. Okay. And we've got Y over here. I'm not sure if I'm going to be using that. So what do we want to find? We want to find that rate that the angle's changing. So we need to find, and again, I like to write it, that we want to find d theta dt. All right, to do that, we're going to set up a formula that relates everything here. And we want to think about, okay, I have the opposite side and I have that hypotenuse given to me. So opposite and the hypotenuse, that's going to be sine of theta equals, the opposite is going to be labeled as x over the hypotenuse, which is not 25, which is going to be z, because I'm thinking ahead just for a second, because that 25 is going to be remaining constant. So I can substitute in constant values at this point here. So if I take this, before I take the derivative, I want to make that substitution that this is going to be sine of theta equals 1 over 25x, okay? So now when I take the derivative, all right, so the derivative of sine is cosine of theta, and then the chain rule I have d theta dt, which is what I want to find, equals 1/25. The derivative of x is just going to be that constant multiple, so 1 over 25 dx dt. And we're going to assume that dx dt hasn't changed, okay? But we do have a bit of a problem, is that we don't know what cosine of theta is. And so I can still relate the parts that I have. So what I'm thinking about is, okay, if I want to figure out what cosine of theta is, I know that cosine of theta is the adjacent side, so y, over the hypotenuse, which is 25, okay? So if I knew what the y was, I would know what the entire cosine theta was, and I can make a substitution there, all right? But I don't know what y is yet. I'm gonna use the Pythagorean theorem to figure that out. I'm gonna have 9 squared plus y squared equals 25 squared. So then I'm gonna get y squared, and then 625 minus 81 is gonna get me 544. And then I take the square root of that, so I'm gonna go, all right, so y equals the square root of 544. And we're not going to use that decimal, so I know that y is the square root of 44, so square root of 44 over 25. And so now I know that cosine of theta is square root of 544 over 25, and let me just throw that in there. For a good measure, feet. It is in feet. So now what I'm doing is I'm going to be solving for a d theta dt with all the information I have. I have all this stuff because I was looking, okay, I don't know what cosine theta is. I want to find d theta dt, and I'm given dx dt, all right? So I needed to do all that extra work over there on the side in order to figure out what cosine theta was. So if I do this, I'm gonna make my substitution, square root of 544 over 25 feet, d theta dt equals 1 over 25, and then dx dt is 2 feet per second. Okay, so now what I want to do is I want to divide by the square root of 544 over 25 feet to isolate d theta dt. And so as I do that, I'm just going to multiply by that reciprocal. So I'm going to multiply by 25 in the numerator over square root of 544 in the denominator, and that feet is in the denominator. Okay, so that's going to be gone on the left side, and I'm going to get d theta dt equals, what is that going to be equal to? All right, so let's see what divides out. The 25s divide out, and the feet divide out. Okay, interesting, interesting. So I get 2 in my numerator over the square root of 544. Okay, we can leave it like that. But what are my units? Well, my units that I get is because this is an angle and we work in radians in trigonometry. So the unit for that angle is being measured in radians. So this is going to be radians per second. And that's how quickly that angle is changing. You can see how it's changing as it's what the angle is doing based off of where that ladder is, how it's increasing, decreasing at certain points in that phase. So we know exactly what that rate is from this analysis that we've been doing with trigonometry and calculus. Okay, so you do need to know all your trigonometry to get through some of these problems. Okay, understanding how triangles work are going to be really effective in your calculus careers, especially with Calc 1 like you're studying now. Of course, if any of this does not make sense or if I was confusing you, please reach out to me for clarification. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.